All right, well, I'll get things started for our online audience. Welcome to another installment of our Sustainable Energy Seminar Series. If this is your first time joining us, my name is Scott Williams. I'm the Research and Education Coordinator here at the Wisconsin Energy Institute. And this seminar is part of our efforts to increase understanding of energy issues among the public. This is the Sustainable Energy Seminar. It's a class held every other week during the fall and spring semesters. It's open to the public, but it's also for credit for students in the Engineering for Energy Sustainability certificate, as well as the Master's in Sustainable Systems Engineering program. And throughout the series, we hear from a wide range of disciplines on campus, from engineering and sciences to social sciences and humanities, to talk about the many different ways that people are researching and understanding energy challenges and developing solutions. We're presenting in this hybrid format here. You're welcome to join us at the Wisconsin Energy Institute building, or you can join us online through Zoom. We do have live transcript on, so you can click live transcript if you would prefer to show captions through Zoom. And please use the Q&A. If you have a question for our presenter, I'll be monitoring that, and we'll bring those questions up at the appropriate time. With that, I'll introduce today's speaker. So Dominic, or Nick Parker, is a professor in agriculture and applied economics here at UW-Madison. His research spans topics in environmental, resource, and development economics, and it includes studies of environmental markets, mining in Africa, resource booms and busts, land use, fishery and wildlife regulations, and renewable energy. Professor Parker also studies the economies of indigenous communities. And today's topic relates to that, which will involve some research as it pertains to renewable energy on Native American land here in the U.S. So,
thanks very much, Scott. Thanks to everyone who's online or whoever is online and those who are physically in attendance. I'm happy to be here. My interest in both the topic of natural resource use and economic development on American Indian lands dates back to my early days as both a student and then later a professor at Montana State University, where I interacted quite a bit with some of the tribal communities in Montana, and then have co-authored some with a friend and economist who's Northern Cheyenne. We looked at some of these issues together related to economic development on American Indian lands. My co-authors in this project are Sarah Johnston. She's a colleague at UW in Ag Econ. Brian Leonard, who is a former student who I advised at Montana State and is now a professor of sustainability at Arizona State University. And Justin Winnikoff, who is a former PhD student here at Wisconsin, who's at the USDA ERS service. So Justin knows a lot about wind energy development. Sarah knows a lot about solar energy development. And Brian has done some research with respect to economic development on American Indian. So that's the group that's working on this project. It's a work in progress, so not a final project, and we're happy to hear your comments, thoughts, questions. So to motivate this, I'll remind us who know, and maybe let you know if you didn't know, that Native American populations on reservations, according to U.S. Census data, are America's poorest minority group. About a third of Native Americans, according to the census, live below the poverty line. 8 of America's 10 poorest counties are majority American Indian reservation land, and so this is a population that tends to be less well off than most other American populations. And this poverty, it seems, stems in part from historical policies and events related to natural resources, policies and events that left Native Americans with poor quality land. And few of the natural resources that settlers from Europe exploited and used to create wealth in other parts of America. So we're talking about good agricultural land, we're talking about later fossil fuels, coal, et cetera. wind and sunshine, when reservation boundaries were formed, when they were adjusted, policies towards American tribes were enacted, wind and sunshine were historically not valuable and hence not targeted by settlers. In fact, wind was a disamenity, tends to correlate negatively with good agricultural land. Sunshine occurred in a lot of places that were arid and were poor for growing crops. Those were some of the lands that were targeted by European settlers and the policies that supported them. It's possible that the formation of reservations disfavored good agricultural land, but maybe favored high endowments of renewable energy like wind and sun. And so that's the motivation for this project, is to ask, can wind and solar provide meaningful economic development opportunities for tribes that wish to develop, That's what the paper and project is asking. So what we do in this paper, what we've done so far, try to measure the raw endowments of renewable potential on reservation areas, and then we compare those to off-reservation sites. We ask if there's some possibility for utility scale development on average in aggregate. Correlate those endowments with poverty on reservations to ask, what are the economic conditions on the reservations that have the best raw endowments of renewables? That's the first part of the paper. And then we look at where the development of wind and solar farming has taken place so far. And we estimate it econometrically. What's the probability that there'll be a wind farm or a solar farm on a particular place? And how is that probability affected by place being native or Indian jurisdiction, Indian country? The point there is to say, once you control for how windy it is, how much access you have to transmission lines, is there a big disparity in realized potential? Preview is there's a big disparity, and we'll talk about that in a moment. And then what we do is we say, look, what if some of these net zero projections, what if the US economy decarbonized, as some forecasts suggest it will? What if some of these net zero carbon emission scenarios play out through 2050? If this disparity between reservations and neighboring areas in terms of uptake of renewable energy, they persist, how much income, foregone income, would tribes miss out on if that disparity persists? And then we talk briefly about some of the obstacles to realizing that potential for tribes that want to develop. So that's what we do. So with that, I will just go into some of the details of what we're up to. I've tried to design the presentation to leave ample time for discussion and questions afterwards, and we'll see if I'm successful sometimes. I'll babble. But, so the first part is, just evaluating these endowments. And I mentioned this a little bit in the introduction, but we know historically that reservation boundaries tended to be gerrymandered, at least in the 19th century, and even in the early 20th century, to avoid overlap with known gold and silver deposits. So this is one mechanism that tribal lands were situated in a way such that they did not overlap resources that were valued by settlers. We know that prime agricultural land within reservation boundaries was often declared surplus through the Dawes Act of 1887 and the process of allotment from 1887 to 1934. Some of that land was privatized and sold, no longer in hands. And that was some of the higher quality agricultural land. And we know that compared to the rest of the US, present day reservations tend to have fewer minerals and fossil fuel endowments. It doesn't mean that reservations don't have prime agricultural land. There is some. It doesn't mean reservations don't have fossil fuel endowments. We know the Crow tribe in Montana has lots of coal. So there's, we know Fort Berthold, the 3 affiliated tribes. North Dakota have lots of shale oil. But just in general, the statistical comparisons show that these lands tend to have less agricultural land, gold, silver, fossil fuels. So the question is, what about renewable endowments? So we try to measure those in aggregate for all the reservation areas. And so what I'm showing here is distributions of wind speed on the left and distributions of global horizontal irradiance on the right. So wind speeds are a measure of wind energy potential, and irradiance is a measure of solar potential. And what these distributions are generally showing is that reservation areas, and I'll show you a map in a minute, this includes federally recognized Indian reservations, but also tribal statistical areas such as those that are in North Carolina, Oklahoma, special case. But in general, what you see is reservations are more endowed with wind and they're more endowed with sunshine when compared to off-reservation lands. So that's just a raw assessment. If you think a little bit more about what those endowments look like, go beyond just windiness and sunniness, and try to account for what's the topography like, how rough is it, how conducive is it for putting a wind farm up. You get the same basic findings. So reservation land areas maybe comprise 4% of the continental US, but they comprise about 9% of the wind energy potential, and about 5% of the solar potential. So disproportionately endowed with wind and sun. So this is potentially good news. The history that I discussed shows that traditional resource endowments are less likely to exist in reservation areas, but tribal nations do have good endowments of wind. Moreover, and this was really surprising to us, moreover, the reservation areas that are the poorest, that have the lowest American Indian per capita incomes, are the places with the highest per capita endowments of renewable energy. So if you think about it, think like, where are these per capita incomes tend to be lowest? Well, some places in the Southwest, some places in the Plains area, in Montana and Idaho, South Dakota, but also in Arizona, New Mexico. Those are sunny, windy places. They're also places where the American Indian populations tend to be lower incomes according to the census data. So this, what I've told you so far suggests to us that renewable energy has some potential to be a double dividend. You hear that term double dividend used a lot. A double dividend, how we think of it, is a policy or a set of policies that could reduce carbon emissions and also reduce extreme inequality and extreme poverty. So this is at least showing that there's some potential. And just to be clear, this first quartile, Scott, you told me not to grab this by the end, and I keep doing that. The dog learns tricks slowly. This is the first quartile. This is I think it's kilowatts. Forget the measurement. Its capacity is kilowatt hours per person. And then the first quartile is the poorest. It's the tribal areas, the reservation areas are ordered in quartiles. That's what economists like to do, is order things with statistics. First quartile is the lowest 25% in terms of income. The second, third, and fourth is the highest. It is the lowest income areas that have the most endowments per person. So that creates a possibility of what we would call a double dividend. But the big caveats are, of course, of not all this technically feasible capacity is economically feasible. Utility scale potential has to account for all the costs to sell the energy. And then those costs are sensitive to availability of transmission lines. So I haven't said anything about transmission lines yet. I will. You know, if you're far removed from a transmission line, you can have a lot of wind and solar, and it might not be an economically feasible place for development. So one example is the Navajo Nation, which had a few solar projects recently, and those projects utilized utility lines that used to be connected to a decommissioned coal plant. So you already had this extensive network of transmission lines. The history of coal development in Navajo. So because those transmission lines were already there, it made solar development a little bit more profitable. So that's the first part. So we're just saying, look, there's some pretty big endowments. They're bigger than neighboring lands off reservations, and they're biggest in the poor really the poorest areas of America. So then the next part of the paper is we say, well, look, where is solar farming and wind farming taken place so far? And, you know, econometrically, if we compare where it's taken place versus where it's not, can we estimate some statistical disparity that might be explained by different governing rules on reservations versus off. So that's this map is the red dots, or the red dots show where commercial wind farming is as of 2021. The yellow areas are federally recognized American Indian reservations, so the Menominee would be there in Wisconsin. And then these gray areas in Oklahoma are, according to the US Census, they're tribal statistical areas. With the recent McGirt versus Oklahoma ruling, I think a better name for them is tribal nations. Makes them more akin to everything that's in yellow, but this is how we made the map for now. So I'll say, you know, wind farming's been really prevalent in Texas and across, you know, the Great Plains. You can see from the map, there's not a lot of red dots that overlap tribal areas, the reservation areas. I mean, there's cases where there's a lot of wind farming going on, like in the Yakima Indian Nation in southern Washington. You can see there's a ton of wind farming right outside the boundary of the reservation, not in the reservation. Blackfeet tribe in Montana. East of it, there's a lot of wind farming, but it's not on the reservation. Of course, Glacier National Park is nearby. So anyway, these are, you know, what we're going to utilize as data to try to estimate additional on windiness. Where is wind farming taking place? I'll get to that in a moment. Here's where here's where the solar farms are. Surprisingly, a lot in the Northeast, surprising to me anyway, along the Southeast coast, of course, in California, Arizona. Not a lot of solar farms on tribal nations either.
We have one question from online. That you talked about that double dividend of including reducing carbon emissions. Are you suggesting the carbon emissions produced by the reservations or carbon emissions the U.S. as a whole in terms of?
Yeah, right. Thank you. Good question. I was suggesting that more renewable uptake could reduce aggregate carbon emissions in the U.S. And the economic earnings from that development could go to poorer tribes. That's the double dividend I'm imagining. But of course, all of this is for tribes are sovereign nations that develop renewables if they choose to, but suggesting there's an opportunity for a double dividend perhaps. Okay, so I don't want to hit you with too many numbers, but this gives you a sense of the estimation that we do in the paper. So what we do, and there's different ways you could do this, but we would argue, for reasons that are probably not worth getting into right now, that what we do is kind of reasonable econometrically. So we look at townships. So our unit of observation is a township, which is a 6 by 6 square mile section, and it's part of the public land survey system grid in the United States. So it just gives us a grid of the country. Some of those townships overlay Indian reservations, some of them overlay federal, Forest Service and Bureau of Land Management land, some of it overlay private land. And what we do is we say, look, how much wind development has there been in these townships? How much solar development has there been? And then we just have an indication, has there been any wind development, any solar development? And so that any turbines of 0.02, that says 2% of the country's townships have wind farming. And then also about 2% have solar farming. And then we also look at the share of a township that's a reservation area, and that's on average about 3% of the country. And then the share of public land, again, that's going to, like some of these states in the West, Nevada has 82% federal land, Montana has 30-something% federal land. So a lot of the sample is federal land. And some other stuff, we have measurements of average wind speed at the township level. We have measurements of transmission lines. How much are they? How close are you to transmission lines from the centroid of a township? Kilometers of transmission is measured for the entire township. So these are things we would think would predict the likelihood of having a wind or solar farm. So too, we think the way the land is used. How much infrastructure is nearby. 10% of the township have airports. 20% of the land is forested. 4% is developed, et cetera. So we want to control for these things. Importantly, the slope of the land, the average slope, the average ruggedness. There's a measure that's pretty vetted in geography that we use for ruggedness. We think ruggedness would make renewable development more difficult. So, what we're doing is we're trying to control for factors we think would predict if you have wind or solar farming, and then try to isolate how the share of the reservation correlates with uptake of renewable to date through 2021, conditional on all these other factors that are also important. So what I'm showing here is estimates from a statistical model that controls for everything we just looked at. And so this is a measure of, does a township have a wind farm or not? Remember, 2% of the townships have one as of 2021. That number will get bigger by 2050. Right now it's 2%. So a couple different models, they control for transmission lines a little bit differently. But the first thing I'll point out is windier places are more likely to have wind farms. And that's kind of comforting to see because that's what we would expect. Townships that have transmission lines, and a lot of them, are more likely to have wind farming. So that's what we would expect. Townships that have a lot of federal public land in them are a lot less likely to have wind farming. And townships that have reservation land in them are also a lot less likely to have wind farming. So this probably confirms, it might confirm your intuition, it might confirm, you know, what we saw on the map. You can see wind farms. You can see wind farms look less like land reservations, but the statistical model is quantifying that difference, and it's controlling for all the other factors we think would be important. So like, if I took this estimate here and I said, how big is that? It means that relative to average, a township with reservation land is about 65% less likely to have a wind farm after accounting for all the things we think would matter, including transmission lines. So that's what those estimates mean. And then we do the same thing. We do the same thing for solar. We say, well, you know, how's the presence of a solar farm predicted by all these other factors? Now, remember, topography is in the model. I'm just not showing it here, so there's less for us to have to look at. But reservations are also a lot less likely than neighboring land. I didn't mention this, but statistically, we have something called a county fixed effect. So that means all these comparisons are for townships that are next to, like townships that have reservation land, basically next to townships that they're next to them, but they don't have reservation land. So it's really a kind of a side-by-side within county comparison. So these estimates mean that reservation land is about 150% less likely to have a solar farm than adjacent off-reservation land that similarly positioned for solar farming. One thing I didn't mention last time, or with the wind slide that I'll mention here, is these estimates for reservations are no different statistically than the estimates for public land, which, you know, this is changing, but up to 2021, or, you know, for the most part, renewable energy development on federal land has been very, very difficult. There, you know, if you were an energy company and you wanted to put wind or solar on federal land, you would have to go through a NEPA review process, National Environmental Policy Act. There would be a lot of rules and restrictions. It would be very difficult to do. I think it's striking that reservation land was no more likely to have renewable energy than federal public land, which as a intent, you know, as a prescriptive policy matter. I mean, we've just basically disallowed renewables on public land. We're getting kind of the same outcome on reservations, even though it's not technically disallowed. Does that make sense? That's striking to me. So those are our estimates. So there's 4 parts of the paper, and I went through the first 2. Endowments are pretty good on reservations. In spite of those endowments, there's a big disparity in the uptake through 2021. We'd otherwise predict there'd be more activity on reservation land if you were just looking at the physical possibilities. So this part of the paper, we asked, like, well, how much money might be left on the table if that disparity persists for tribes who wanted to develop? So what we do is we look at this Princeton Net Zero report. And these are really back of the envelope calculations, but we take these net zero estimates of different scenarios for decarbonization in the US economy. And then we multiply our estimates from the model that I showed you by the forecasted rate of solar and renewable or solar and wind growth across the whole country. So it's for onshore wind farming and for utility scale solar. So there's these estimates of what's going to happen across the US under different energy scenarios. We just say, look, if the US is going to grow like this, and this disparity coefficient persists, or reservations would grow like this, as they've done so far, how much money is lost through that? And so that's what we're trying to do. So the way we try to do it is, we need some numbers for these simulations. And so what we say, well, what would, the tribes and their members own the wind and solar? If they want to develop it, one way to monetize the returns is thinking of what economists would call economic rents or rental returns on your resource or your asset. You rented out your oil development rights, you'd get a royalty payment or a rental return. If you rented out your wind and solar as a landowner, you'd get a lease payment. And, a really conservative kind of low-end estimate of what lease payments have been to private landowners in recent years are numbers that we use in our simulation. I'd say these numbers are going up, so these are conservative estimates of how much people are making. And then another rental return could be tax payments to government. So, if there's wind and solar development on private land in a county, the landowners get the lease payments, and then the local governments get property tax payments. And presumably, the private landowners are beneficiaries to those payments. So we're making the same assumption about tribal governments. We're saying, look, if there was wind and leasing and solar leasing on reservations, the owner of the land would get lease payments and the government would get tax revenues, and presumably the constituents of that government would be individual claimants of those tax revenues. So those are the assumptions we're making. And then we take these decarbonization scenarios from Princeton's net zero report, and we get a table that looks like this when we do the simulations. The simulations are of these 6 scenarios. And so we're just saying, like, how much this total column in the back, or the total for everyone, is what I want to look at. So if we add up, kind of, if that disparity just hangs around, like the one that we've observed today, persists through 2050, under the least aggressive renewable scenario, tribes would lose $6.9 billion in foregone earnings, and that's a present value calculation. It's an estimate of the foregone value of future rental payments for your wind and for your sun. And then under the most aggressive payment, it's $23.3 billion. And again, sorry, I'm saying this in a clunky way. We take these forecasts and we say, solar and wind are going to scale up over time. So some of the payments won't happen for 10 or 15 years in the future. We're discounting those future returns, so they're worth less than returns you'd get sooner. We add all those up, we take the present value, we say, well, that disparity persists, foregone earnings under the aggressive scenario would be worth $23.3 billion today. And we divide that by the American Indian population living on reservations to get a per capita estimate. That amount is 13,000 to 44,000. But then if we just think, well, it's really a smaller subset of reservation areas that have really good wind and solar, we just think of that 25% that has 96% of the total capacity. And that number is bigger. It's like 20,000 to 65,000. perspective, according to the census, which I know is may not be accurate for measures of American Indian income, that flow of income in 2018 was about 15,000 per year, so that's a comparison. We know casino profits, roughly speaking, are in the range. We took like annual profits from casinos, which is proprietary, so you make some assumptions about how revenue translates to profit. These renewable numbers are about half of the flow that's better in aggregate nationally from casinos. But again, these Indian reservations that have a lot of wind and solar, these are remote, poor places that don't have casino gaming opportunities. It's just there's no demand for it there. So casino gaming has hit a different, it's benefited a different set of tribes economically, and those are not the tribes that would likely benefit from that. Does that make sense? So I'll skip over this, but I'll just say these are back of the envelope estimates. We could be underestimating or overestimating reality, but that's struck us as a reasonable way to estimate things. So part 4 and the final part of the paper, Arnold, you would have probably more insights than we do on this, but so what's going on? What explains the disparity? Why has there been less uptake in townships with Indian reservations compared to other nearby townships that have similar wind and sun? And so there's 5 reasons that that my tribal friends tell me are important and that the research says is important. So we list them in the paper. One possibility is, a subset of tribes have no interest in commercial renewable development. That surely is true of some tribes don't have an interest. It's also true some non-Indian landowners don't have an interest. But we do know that there are a lot of tribes, members on tribes that have pursued renewable energy development, and these projects have fell through at a much higher rate than off-reservation land. So even places that have signaled a strong interest in renewable development have sometimes and often not saw that happen. So that's one possible reason, but we think it's surely, or we know there's places that want to develop it, but have not been able to. Another reason I'd call trusteeship, and what one of my friends, Ernest Zicki, Cushado tribe in Louisiana, calls white tape, which is, sometimes we think of bureaucracy and red tape as making development difficult. Surely there's a lot of bureaucracy and red tape to renewable energy development. But he calls it white tape because, these are, in a lot of cases, it's federal bureaucracy that was set up by white people and white interests. So that's, one example is just thinking about what it takes to get an energy lease. It requires approval of the Bureau of Indian Affairs. The president of the Navajo Nation has complained about red tape and said, renewable policies aren't going to benefit tribes unless it's easier to get development. There's some poor record keeping in the Bureau of Indian Affairs and some understaffing that's delayed permitting of renewable energy. We saw some of the same things happen with oil and gas. There was one study that suggested there was 49 regulatory steps required for oil and gas development on reservations compared to 5 off reservations. So this problem is not unique to renewable energy, but it's one reason why it's difficult for tribes who want to develop renewables to get things going. So I don't know what the consortium is doing, but maybe it's a found a way to streamline some of the regulatory processes.
I don't know how far along they are. My guess is that, although they may know a lot more than they're leading on to, I think they're not a whole lot further down the road than the tribes they hope to help.
Yeah.
I think part of the issue too is, at least from my perspective, I used to own a propane gas company, and so I delved into a little bit of the natural gas perspective. And utilities are very reluctant to deal with tribes for the sovereign part of the tribes. You know, they can walk away from a deal and not have any harm done to them. And it's assumed that it would be the utilities that are going to build this infrastructure.
Yeah, yeah.
Which is, I don't know, technically how there's any tribe, you can always hire people, but they're highly expert in their fields. You know? So
yeah, it's very specialized.
right, if you can build it, but somebody's got to maintain it, right? I mean, even David's got experience in building solar energy. I wonder how much information is out there with regard to, is there a lot of any of this going on anywhere in Indian country in Wisconsin?
I'm working, I have an RA working on an inventory of that, so we should check in another month or so, trying to get a better sense.
But I mean, given the amount of brick and mortar out there that the tribes own themselves, you put solar panels on every one of their buildings and it would be profitable. But then again, it's the transmission lines, who owns those nowadays?
Yeah, well
It's hit and miss. I mean, there's argument over who does own it.
Absolutely. I mean, you have a web of, if I march down this list, you know, there's the land ownership fractionation and fragmentation. And so just for those of you unfamiliar, a lot of the land that was originally allotted historically, it was allotted in 160 and say 80 acre parcels, and it was slated to be privatized, and then just fee simple title. Before that happened, for a lot of lands in 1934, the process stopped with the Indian Organization Act. So any land that hadn't already been privatized often has become heavily fractionated. So all the heirs of the allottee has acquired an undivided interest in the land. So sometimes pieces of land will have 20, 25, 30, 35, 100 owners. Sometimes it's difficult to find the owners. The Bureau of Indian Affairs is charged with keeping track. Hasn't been able to do that successfully in a lot of cases. So if you want to get a land use change approved, the owners have to consent. So how do you get 100 people? 5 people. And then if it's wind farming or solar farming, maybe it's easier for the solar panels. You would have to get neighboring landowners to consent. Each piece of land is owned by 15, 20 people. Contracting problem blows up pretty quickly. So this sorry, oh, it's okay. This fractionation of land, just to give you a little idea of what it looks like on some reservations. This is the Fort Berthold Indian Reservation, and there's allotted land that is often fractionated with multiple owners, and there's land that's owned by the tribe, held in trust by the federal government. There's little pockets of fee simple land. So, you know, a study I worked on with that fracking, with that oil and gas development during the fracking boom from 2010 to 2015. And those parcels that had a lot of fractionation were right next to all kinds of fracking activity that was really disruptive. But they themselves weren't earning money from the fracking because it was so costly for the oil developer to find all the owners and make a deal with them. So it's really been a development challenge on reservations where there's fractionated land, and that's important for renewable.
You know, David and I both worked with the Indian Land Tenure Foundation, which is the.
Oh, yeah, I know.
You're familiar with it? So we're keenly aware of their struggles that they've had.
It's such a big
identifying whether it's oil, gas, whatever.
Oh yeah,
minerals in general. It's amazing.
Yeah, it's amazing. Such a hard nut to crack, too, right? I mean,
of course, you're familiar with the monopolies being terminated and subsequently restored.
Absolutely, yeah.
And the headache that even to this day, county land versus fee land versus trust land, to get something placed in the trust, which the tribe does as often as they can afford it. It's a process in and of itself as well.
And in conversations with Sharon, more about that. Yeah. Just on your last point, I guess these are related. Perceptions of tribal rule of law. Some outside developers are afraid of sovereignty, and then there's this lack of transmission lines, and all these things are related, right? I mean, how do you get transmission lines when you have 3 agencies that might have regulatory authority and you're not sure, there's uncertainty. So, you know, I do know some research, some of it with one of my co-authors, who has found some positive effects of tribes that have passed secured transaction laws. I don't know if the Menominee is considered in secured transaction laws.
I would think, belief would be that they haven't. They're afraid of it. They don't want to. They perceive it as given up. Yeah. They're only
giving up control.
Giving up control. Period.
There is some evidence that those tribes that have enacted them have got some development as a result. And there's also some evidence that the tribes that have tailored secure transaction laws to try to fit more with their individual preferences rather than just adopting the have attracted just as much development. So there might be a possibility to thread that needle and keep things the way, attract the kind of development you want to attract and not the kind of development you don't want to attract. The jury's wow, it's just one study.
I was going to tell you about you talk about things that are not only government entities or not only people, but government entities. There was a tract of land that the Menominees had purchased back, and it was formerly called the Vollins Farm, which is now they call it Middle Village. It's a development now owned by the tribe. Supposedly that land was supposed to be transferred into trust. To this day, Shawnee County won't release it. If you can imagine what kind of contractual problems that would bring between the county and the tribe, and well, actually that Menominee County, Shawnee County, and the Menominee Reservation all having a seat at the table, but how does that get resolved?
Well, I'll just wrap up. Scott, I know you're close to your deadline, and I'm done here. I'm just, these five candidate estimation or explanations, and this lack of transmission line is a big one. But I'll point out, that it, at least according to our statistical model, even if we could drop transmission access from the sky closer to reservation areas, it wouldn't account for very much of the disparity that we're estimating, which surprised us. So places with access to transmission lines are more likely to have wind and solar farming, but it doesn't explain the majority of the disparity in solar and wind farming. So there's, of course, a lot of contractual, regulatory issues that are at play here. And a lot of them are related to fractionation and fragmentation. Okay, so I'm going to conclude. I really appreciate the discussion. Thanks for everybody who's here. Let me just read these points. Renewable development is possibly a double dividend for tribes that wish to develop, but many challenges exist. Solutions will likely require regulatory changes. If the problems are not addressed, it doesn't seem like tribes, American Indian populations, are gonna get benefits from the federal and state renewable subsidies that are generating development off of reservations at a pretty fast clip now. And I'll say one other thing, just to be clear. None of these findings are meant to suggest tribes should lease land. This decision should be a sovereign choice for tribes and their members to determine. This is not a call for the federal government to impose its energy priorities onto tribes, as has been done in the past, say with hydroelectric powers and dams. But we did want to study this and try to get a sense of what are the possibilities and what kind of money are we talking about if disparities could somehow be mitigated. Thank you for coming, and this is where we're at with the paper.
We do have a couple questions online. I'll try to summarize them. I guess the first one, it relates to more kind of the ownership structure. Megan asked about access to capital as being a contributor to preventing development, and then I guess related to that, as a whether or not as a tribe owns the infrastructure, or if there's a willingness to work with the outside developer, if that sort of giving more of the benefits to the tribe itself rather than just the lease payments and just the tax, if that's a barrier to more development.
Yeah, seems like a nice question. So development could happen through two paths. One is an outside developer offers lease and tax payments, and then it's done via contract, or the tribe itself has a facility and generates its in the latter scenario, the tribe is going to have to raise money for the capital if it doesn't have it. Capital requirement. And then how will it do it? I mean, it could raise money through bonding. Tribes tend to pay pretty high interest rates on it. The tribe is trying to raise money. It would likely have to use some of its assets as collateral, land being one of them, but the federal land being held in federal trust does make it more complicated to leverage land as collateral for a loan. But it does seem like there is some possibility there for tribes who do it on their own to generate a larger return on their wind and sun, subject to getting the capital on the ground, which has proven to be a big problem for reasons we've been talking about. If the tribe is a sovereign nation, does the lender feel like they have recourse if there's a payment? because of history and poverty and resources that were stripped from tribes. Some tribes and their members don't have a long credit history, so that makes the cost of lending higher.
And another question I'll try to summarize, but solar and wind farming doesn't come without consequences to the land itself, and so rather than thinking about these lands as sort of I'll use the quote sacrifice zones, what other alternatives beyond hosting renewable energy on native land could tribes have? Maybe either getting reclaiming more land for the tribes, or what are the impacts to the land that might be an issue that tribes might not want to develop on their land?
Yeah, I mean, we know from economic studies that some negative association with wind turbines property values, and that's telling you that wind turbines can be a disamenity for a lot of communities and it's not just the wind farms and the solar farms, it's the network of transmission lines connected with it if it's utility scale. So this is not a free lunch by any means, whether you're on a reservation or off a reservation. So yeah, I mean, there are some possibilities probably on, I know there's possibilities on those 25% of the reservations that have wind and sun. Some of the parts of the reservation are pretty far removed from communities, where people are living, so possibly the amenities would be less potent. Certainly there's a lot of, certainly there's drawbacks to developing tribes and have
Other questions?
Any interest in non-commercial development of local use?
Yeah. I'm definitely interested in it. We don't do anything with it in this paper, in part because we don't know quite how to quantify it. It's like tying economists' hands behind their back if you can't quantify it. But distributed energy, I mean, there's some that could be the way to go for some tribes, I would think.
Solar is very nice because you can use it right next to where you generate it. You don't have to transmit it.
Yeah, exactly.
If there's any demand or way to finesse that characteristic of solar, wind to a degree.
There's certainly interest in energy sovereignty or energy self-sufficiency. Getting on the grid and selling utility scale is a question. What do you think we could do to probe that?
I think that would be the line which the tribes would be following. Just trying to get the tribes to talk about commercial scale or utility scale investment. Big jump. I think we would be experiences in this Midwest consortium is trying to provide assistance to tribes to develop renewables. We've been following this least resistance line. The easiest way to use renewables is locally. So there may be tribes that have the resources to make those level of investments and then see what happens. Or if you had a consortium of tribes, like the 12 tribes in the state of Wisconsin, that would band together for the purpose of financing.
Yeah.
I mean, the brick and mortar facilities alone, if they were to provide the energy for those alone, they would be saving themselves a hell of a lot of money, I would think. Casinos and travel buildings.
That's a great point. I mean, you know, pooling together resources both for raising capital and also for sharing returns.
Oh, a lot of them too have an awful lot of housing projects. To energize housing projects alone, that would be something.
This is a big debate, not just tribal, non-tribal is. Why is it that utilities are not exploring distributed investment patterns, microgrids and local generation and distribution? And it's a big problem of our system. We don't have.
They're not well incentivized to do that, are they?
No.
David and I have attended a few meetings with the big boys, and as soon as I start talking tribal to them, they kind of shut up. They don't want nothing to do with no tribes. They really don't.
Well, they don't want to.
Well, I think the sovereignty thing is one.
It's not just tribes. It's the local.
They want a monopoly.
The local investment option. There has not been a way to incentivize utilities to get them out of the way, or let alone doing anything positive.
Yeah.
So it's really, it's not just a tribal issue. But I think but your questions that you're raising for commercial scale is I would think that this fractionated pattern of ownership, you're talking about a large scale commercial investment, I don't see how that can be. The Menominee opted out of that.
Yeah, I know.
The only tribe that's got.
I know. Well, that's what we found in Fort Berthold was the areas by the river that was dammed. The 3 affiliated tribes retain subsurface rights. And these areas were pretty profitable because you had one entity. You still had collective ownership. You didn't have all the fragmentation
kind of situation.
Yeah. So if those subsurface rights were sort of reconsolidated, Cobell was attempting to do.
There's a Supreme Court
resources.
Supreme Court case coming for tomorrow.
I saw that. Yes.
Which is an attack on tribal sovereignty.
Indian Child Welfare Act.
Right.
My friend Robert Miller is quoted in that. He's a law professor at Arizona State University, and he's very worried.
Well, it's the attack on this concept of sovereignty, a sovereign nation. That's the one feature of the tribal puzzle that is positive sides to that.
How do they with the Oklahoma situation, how do they mesh that with potential adverse decision by the Supreme Court against the Indian Child Welfare Act? How do they do the Oklahoma situation?
It's a big danger. It's a big danger right now. The whole thing can collapse. Then there would be really hell to pay.
There was one justice different in Oklahoma. Well, thank you for having me. Thanks for coming. Discussion was really helpful for me. And grab your names before you leave so I can try to stay in touch.
Maybe I guess one more quick question from online. Did you consult with any tribes that have been successful in deploying renewables, such as the Kumeyaay Nation or Native Solar and Navajo Nation?
We're working on it. Yeah, we're trying to get some interviews. Yeah, thank you for that.
Thanks. Thank you so much for your presentation. Really appreciate the discussion.
Thanks for having me.
I'll try to get you a copy of that Menominee